tracking system that was used in this room, we actually had the camera on the HMD. HMD or head-mounted display, the goggles. I'll use HMD a lot, and that's what that means, is the headset. Right, so we had a camera on it looking outward at these traditions on the walls. Now clearly, that's not a very commercial system. People aren't going to want to wallpaper their rooms like that. But this gave us back in 2013, room scale, virtual reality with sub-millimeter level tracking. But once we had this, what we learned was the image was smearing heavily as you moved around looking. So then, before having this decisive tracking, you live with that smearing, but you really noticed when you had this good tracking. So this became our method of working. You resolved one problem, tracking, to find the other problem that it was hiding, smearing, and you repeat. You keep getting closer and closer. So we worked on solving that, and that was with low persistence displays. At the time, the only way we could get those displays was we would buy mobile phones on eBay, tear off the panels, we call them panels, they're the displays, and then we would actually rip those out of the phone, hook them up to our own boards, our own circuit boards, and to drive them. And we're only using half of the panel, but we have two each because we got to globally display at the same time. And so now, all high-end VR has low persistence, and I think all of them use two panels. I know Oculus does for sure, I'm not sure about some. Right, but so along with this is back in 2013, and along with other advances, was back then, with the low persistence and the tracking that brought everyone to Seattle to see our room. Later we would build rooms for other companies. Later we would build rooms for other companies that were trying to help us succeed in VR. But at that time, we're still about research. Approaching it that way really freed us up. It let us do things like keep changing the tracking method and not worry about switching costs. Because the only people paying that switching cost were our own internal developers. So that's how we ended up with lasers and HTC. People always want to know how the two companies met. On the surface it seems like an odd match. And while you can use cringe-worthy words like synergy and alignment, the truth is much simpler. HTC was looking at and experimenting with VR. The chairwoman saw our demo and instantly knew she wanted to make it real. So much of the way the room changed the course for other companies, this time it changed the course for Valve and HTC. Instead of us being purely research, HTC would work with us on experimentation and our design, take those experiments and make them into a reality. So HTC is the reason that I'm here talking with you about virtual reality. Virtual reality that you can play out right now on the show floor, and then you'll be able to have it in your homes really soon. So that's the history lesson. But for the rest of this talk, when we're discussing virtual reality, this is what I'm discussing, that level of high-end virtual reality. And since at Valve we've had it for years, we're now familiar, there's a lot of things that are familiar to us or obvious to us, but they may not be obvious or apparent to others. So let's try to clear up some of that confusion. Remember, all this is still really new, and we're still trying, and we're still learning. Okay, so let's get down to some of the points you see coming up that confuse people. I was going to make a list. Number one on my list of things I hate is making lists. There's no lists. All right, but if I don't cover something that confuses you, or you have some questions, there'll be a Q&A after the talk. You can go up to the microphone and ask me, or we'll be around all week at the Vive booth. All right, so the first thing you notice about high-end VR is the cable. You have that cable for a few reasons. The bandwidth is the biggest. So 90 times a second, we're pushing 2 HD screens worth of data down to the headset, the HD. And we can't have latency or compression in the traditional sense. The problem with wireless technology is, a lot of the technology being made for VR is new or using things in new ways. Wireless technology is actually mature technology. So we're not going to see the rapid advancements there that we may see in other parts of the virtual reality system. So we don't think we're going to see all of a sudden the ability to stream a ton more bandwidth. Why theoretically this generation we can get close to what we need. Next generation we're going to want to have 2K each eye, or we're going to want to have 4K each eye. So eventually what happens, my guess is that computers are just going to keep getting smaller and smaller. But there's some problems there as well, because you have battery life, heat, and other constraints. Just the point where physics gets in the way of having that happen. So for now, high-end VR, you have a cable. And you're going to connect those cables to a beefy PC. Remember when I mentioned low persistence displays? So this is what low persistence really gives you. you move your head, you're looking at exactly what you're looking at. And we do that because we flash the image globally, so all the pixels at once across both screens. And we do that for 1 millisecond, and then we turn it off for 9 milliseconds. So that means you're actually seeing black more than you're seeing white. But you don't notice it because we do that 90 times a second. So the panels are running at 90 megahertz, which means the content we send to those panels needs to run at 90 frames per second. So when you hear that 90 frames per second, that isn't some arbitrary number someone came up with. That's the physical number that you have to hit every single time. It isn't actually really 90 frames per second because there's slack in the idea of 90 frames per second. It's really 90 times a second you hit G-sync. You have to hit it on the beat. So that machine, the program really needs to be performing, so it needs to be connected to a high-end computer. But talking about hardware requirements is also kind of odd because I can make something right now that runs on a 5-year-old video card. It's just going to be super simple and not very interesting. So when we're talking about system specs that you need now for virtual reality, what we're really doing is saying is, here's the minimum spec that most of the experiences will run at. And this allows then developers to target those cards and all for their experiences. So you don't get nice panels and screens that we're comfortable enough to look at for hours without the need for a computer. Besides visuals, audio is also very important in virtual reality. There's a lot of confusion about audio in VR, in particular the phrase 3D positional audio. So first, let me make no mistake, the audio is very important in VR, and it's very important to us working on the Vive. I don't mean to dismiss it. When we think about it, your brain uses audio all the time to help you understand space, to help you navigate. That's super important, and it's super important to get it right. But I have some good news for you. 3D positional audio is nothing new. When we create experiences for VR, we almost always use a game engine. And when we do, and what game engines have since the 90s? 3D positional audio. First-person video games have simulated a listener, the camera, relative to location-based sound for decades. Think footsteps from Counter-Strike. Right? These are important because they give you information about the world, orientation to left and right, and the distance. The misconception that 3D game audio won't work in VR is false. In fact, due to your ability to make, for the listener, to make small movements in their head very quickly, the 3D positional audio actually works, the game audio works better in VR than it does in the games. So right now, because all HMDs and positional tracking work with 3D game engines, they all have 3D positional audio capability by default. It is up to the developer to utilize it correctly. Right, but binaural audio. So what binaural audio is it makes you hear the sound as if it's hearing it from your own ears. There's a very famous YouTube video of getting your hair cut. If you're listening with headphones, it sounds like someone's actually cutting your hair. So first, binaural audio is only relevant to the contents of headphones. If you had no headphones, you make a room like this. A bunch of speakers that are all playing sounds out of the right speakers that you position here. The problem with this is as you move around the room, the audio speakers have to adjust for your movement in that room so it sounded correctly. Not get complicated. Second, binaural recordings, you can't record binaural audio in real life and use it in VR with positional tracking. Because when you record it, the sounds are set to the relative position you recorded them. And since in VR and games you can move and look freely, the moment you do that, binaural recording will no longer reflect where the sound is coming from in the virtual space. Real-life binaural audio recordings will always reflect the angle and position at which they were captured and never respond to the players looking or moving. So given that we can't record binaural audio, we have to simulate binaural effects at runtime using software. What do I mean by simulating binaural effects? So I'm going to replicate the effect we're going for. So I'm going to play some white noise our sound designer Emily gave me while you look at the pictures of my cat and move your head around while listening. That's what we're trying to simulate and replicate in virtual reality. To do that, we use filters, binaural HRTF filters to simulate this effect, which help us tell where the 3D audio is coming from. The weird thing is, we've tried all the solutions. Some are better than others, and sometimes the untouched, raw, unfiltered positional audio is still better. But, that's going to be now up to the developers to decide they want the processed audio or do they want to use the unfiltered. So, and that's all of this. 3D audio refers to sound sources within a 3D game engine that have XYZ coordinates or respond dynamically based on what the player is looking or moving. All developers that work in 3D engines for VR are able to choose from a number of different software solutions to enhance the default 3D experiences. A little fun fact, 3D audio in games in VR is actually made up of a bunch of mono assets, not stereo. Why mono? Because you don't want to have any positional data baked into the asset. It'd be like baking in lighting or shadows into a mono. So that's audio. Hopefully that makes some sense. Next up is input. The first time anyone goes into VR, they reach out for things. They want to touch, they want to interact with the world. The first time we had a track controller, it shocked us not just because it wasn't just additive, it was exponentially better. That when you can reach in, when you can interact with the world, your brain's belief in buying into that system grows that much stronger. Another thing we learned with early experiments is that you need to have low latency. We were surprised that how much latency affected input as well. It just wasn't head movement that makes you sick. But if you had low latency in your input, your body just didn't like the way it felt. So for input, we experimented and we talked with everybody. We also saw everything we could. We've had every type of input through our doors, so you need to keep an open mind in these fast-moving days. But it isn't by coincidence that Sony, Oculus, and ourselves have landed on somewhat similar to input device for this first round of VR. Something you hold in your hand, is tracked, and has input. I don't think anyone's going to say that's the end all of input. It's a good starting point to get the community and keep testing and exploring. And one of the reasons for now why it's the winning design, after much exploration, besides it working pretty well, it also has obvious failure cases. When you have a way of input, you want it to be something that works naturally without thinking about it, and if it fails, the user understands why. And so if you haven't tried these devices, you might be thinking Wiimotes, you'd be wrong. Up to this point, games have really been about abstraction. You're using imprecise controls, looking at a 2D screen, trying to control an avatar. In virtual reality, you're in the scene with precise controls. It changes everything. And tracked input lets you affect the virtual world just like you do in the real world. That's something we see with developers as they move from the 2D world to virtual reality, is sometimes how you open a door is you open a door. And it's kind of mind-blowing of how simple that works. So let's cover some of the other input methods people discuss. Eye tracking. Your eyes do an amazing job of looking around and interpreting the world for you. But how often do you think, let me look at that, and then just move your eyes, not your head, to look at something? I'm going to guess not that often. If you do it now for the next 10 minutes while you're bored listening to me, you're going to find out it's also really fatiguing. And at this moment, it's also problematic. We've seen failures because people have too long of eyelashes, because somebody had LASIK, or it just fails. And much like a lot of the tech here, it keeps getting better. Every time we see it, it's better and better. It's going to be really interesting to see where it goes in the coming years, especially for things like foveated rendering. But as input, it just isn't how we interact with the real world. We're used to touching things, physically interacting. In the real world, you do know where someone is looking. And that's important for social interactions. So right now, we can track where your head's pointing, but we can't track where your eyes are pointing. So that may become an important part of what eye tracking does for us in those social interactions. We can actually see where somebody's looking. Voice input. You can control your computer right now with voice. There's software that does it, so why don't you? For me, personally, I find it tiring and unnatural in some ways. We may adapt and get better over time as we yell at our TVs, consoles, and phones, but for now, it's inconsistent, and it's not good at precise controls, and not how we interact in the real world. It also raises one other thing to think about when you're thinking about input. Commanding something with your voice is a cognitive load. You have to think about what you're saying before you say it. That ends up pulling you out of the experience. That breaks the feeling of presence. You want your input to be natural, something you stop thinking about. So what about full body tracking that Hollywood has promised us, or at least parts of your body, like your hands, being tracked? Well, maybe in the future, but we aren't there yet. In that classic Hollywood shot, those arms straight out, interacting like that, some groups actually use it as punishment. Try it for 10 minutes just holding your arms outside there. What they call gorilla arms. It's exhausting. One of the amazing things you notice when you first start experimenting with input, your hands do a lot of things without you ever looking at them, right? You can write things, you can steer a car, you can shift gears, you open doors, all of that happens without you looking at them. So if you're tracking your hands, you need to track them wherever they are, not just when you're looking at them. And also, for a current round of input, by holding something, we can also have haptic feedback. There's something about when you reach out and you touch something holding one of the current controllers, and you feel that little touch, that makes it so much more real. Your brain expects it, and when it gets that payoff, it's just happy. So you want to have that as well. But to step back to the track input again, it isn't just about buttons, it's about interactions as input as well. We have a really simple demo. It's called longbow. It's a bow and arrow demo. So you can see the bow and you know to pick it up. But where are the arrows? Most people don't even need to tell, and we do need to tell someone, we only need to tell them once. They're in the quiver behind you. You just reach back and you pull it out, and it's there. It's not about buttons for input, it's not about hitting the reload key. It's about doing something physical in the world that your body understands is right. Your body instantly gets used to it, it's a really great way of input. But it also shows the beginning of what people will start doing as we start getting more and more familiar with this. Again, this is all so new for developers that they're just learning these kind of tricks. So now on to movement. The first thing people think of for virtual reality is the holodeck, running around in a virtual world. There are problems with that. A current set of movements where you're pushing a joystick forward, hitting on the W key, I don't get any nauseous. They're the easiest way to get somebody sick. So, one of the first things that influenced our choice for room scale back when we had the traditions on the wall, you could take a new gamer, you could take a hardcore gamer, and you could say, go over there to that model that's 2 feet away. And everyone knew how to do it. They just walked over there. There's no hitting of buttons. There was no pushing of anything. You just walk over, kneel down, and inspect it. It was very natural to you. In VR, you physically react when you see something larger than life, right? You step back, you move, you physically react to it. You tap into the VR with your presence, your body wants to participate in it. One of the coolest things I've seen recently was playing something that's not announced yet, and it's self-game, and you're moving around, and I peered around a corner to see what was in the other room. I did that by peering around a corner. That was it. And it's one of those things you do it, and you're like, well, yeah, of course, you peer around a corner. I've never peered around a corner before in a game. I've always pushed on some combination of keys, held some key down while I hit the S key. There was this moment when I realized what I was doing, that as a game designer, my head kind of exploded with the possibilities of what we're really getting ourselves into. Okay, so that's localized motion in room scale. And to be clear, I want one takeaway from this talk, nothing else. In that room, you can go up to 5 meter by 5 meter. That's the maximum. Okay? That is not the requirement. Right now, you can walk over to our booth or to Frontier's booth, and you can play Elite Dangerous sitting down. So room scale VR isn't the requirement that you have a 5 meter by 5 meter room. It can scale all the way from sitting to that large. Okay? So I'm going to repeat it one more time, because there's a lot of confusion about this. Room scale VR does not replace the other VR, it's additive to it. You don't need a 5 meter by 5 meter room. We know most people don't have that much room in their house. So it supports everything in between. So why room scale then? Besides the localized motion, when you watch things, when you listen to things, what do? Like today, you're sitting in a seat. Your body for years of training equates sitting with watching. You stand up, move around, you stretch, you're ready for the action. And part of it is your body's also scared because now it feels vulnerable. You're standing out there, there's nothing protecting you, you're active in the scene. And this time, because now it's exposed, you're standing in the center of the action, this time literally, not figuratively like most game apps would have you believe. And I give myself 50-50 that I use the word literally correctly there. Okay, so back to movement. Movement outside of your play area changes things. These are the early days of experimenting, trying things to see what works. And all VR systems are experimenting with what this looks like. This isn't just a problem for room scale VR. And one of our main thoughts is you don't mimic the real world. So this is what Hollywood did. This is the movie Disclosure. And so Michael Douglas puts on the VR gear, steps on a contraption. He's going to book a file, and he actually has to do it quickly. So he does it quickly by walking down these cavernous halls to the file cabinet room, where he opens the door, walks down into the room to the file cabinet, where he opens up the file cabinet, pages through, picks up the file, opens it up, and shoot. That is a horrible UI. It's a horrible interface. VR lets us do new things, not mimic the old ones. And so one of the things that's going to happen is, as people try these different ways of movement, as they try to see what works, because it's going to keep changing over the years, you in the community will have an impact in the future of VR, and that's important. This isn't like going from one console to another where it's a visual upgrade or slightly different control scheme. This is a fundamental different experience. We're all learning this together. So, it's so different that before we meet somebody to talk about working with them in virtual reality, we make them see the demo. Because there is a different conversation after they see the demo. When you get a chance to try it yourself, hopefully, here at the show, give us feedback. Tell us what you want. Tell us what you want to see. And this isn't about us versus them. We're all working in this together, and with the developers to make sure that VR succeeds. So tell everyone. See the slide. All right, I don't know right there. Okay. So locomotion lends itself to the next problem. That's what we see the most often is people getting nauseous. Okay? And the idea that VR must keep you sick is BS. We have a bunch of people who will come in for demos who don't want to do demos. There'll always be somebody like there's a party of 10 people come in, and be somebody who's like, oh, I can't do this, I'll get sick, I can't do this. That's because of expectations of either what they've seen before or what they've heard. So as consumers, as people who are going to purchase this, as people in the community, hold developers to it. They shouldn't be getting you sick. It's no longer the hardware's fault anymore. It's developers making choices that are getting you sick. So tell them that you don't want that. Okay, so now on the 360 video. So this is a hot topic right now, and with a lot of excitement and investment around it. 360 video went from something you check that on your computer monitor to meaning VR. But for VR, the sports physical tracking, it runs into the same problems we have with binaural audio. While the race can be complicated and look like something out of a sci-fi movie, they're just recording events from a single point of view. So think of it. If you wanted a 360 video of this talk, you can put a camera right there. It'd be a really nice view. If you're on your computer screen, you can look and you can scan the crowd as well. It'd be a neat experience. If you do it in VR with positional tracking, and you move your head to the left, you expect to see more information. You expect to see more things about the right side of my head. But if you're right, and so right now, if you all lean to your left, right, you're going to see more information. And people further back in the room will see less information. People towards the front will see more information. And that's why a lot of 360 videos film from something 10 feet away without getting close, because they're trying to hide that problem. But the thing is, in virtual reality, you want to get close to things, you track things, you want to hold them. It just makes it magical when you're able to do that. The other problem is you expect to see that head movement back to you. So if you're looking at 360 video, and it works actually oddly well in headsets where you don't have positional tracking, because you don't expect to see those things reflected back to you. But positional tracking, you expect, when I move my head like this, I should see what I see moving my head. When you don't, that's when you can get nauseous, and that's when you can get sick. How do we fix this? How do we capture live action where you can see all the different angles? I don't know. There's a lot of companies chasing it. It still isn't there yet. And people keep saying things like filming in VR when they really mean filming in 360 video. So it's a really confusing time right now. But to be clear, you can capture 3D data now. They also own Adam Foster just did a great blog post on steamvr.com about photogrammetry. Sorry. Jet lag. Well, not jet lag. It's a process that lets you take a bunch of photos using just a regular camera of an area, and then you recreate the scene in VR, and it actually lets you walk around and move in that scene. You get close to things. You see the paralights as you get close and move around it. So this is a shot from there. This is from our offices, and they put Peabody inside of our office. So you can scan sets, scenes, areas, and recreate them and walk around in them, like you do in that scene. Adam even went to Iceland and scanned a bunch of physical nature scenes and did the same thing. And it's really believable. You think you're there, your body buys into it because all the ways you're used to seeing information reflected back to you. It's time consuming, but the one thing you don't see in it is live action humans moving. Which is kind of the classic thing a lot of people say VR is you're going to put that camera down and right on the pitch, you're going to be able to see the entire game in 360, move your view everywhere. We're not there yet, right? It's time consuming to capture soft human shapes and motion. And you need all the data from all the angles, so we're just still not seeing that happening yet. But then there's things like what Lionsgate, Starbreeze, and Weaver are doing for the upcoming John Wick experience. We have a full 3D scan of Lance Reddick, who plays the hotel manager from the movie. There's no video tricks. You're in the room with him. You can get close, you can check him out, you can walk around him. The cool thing is, kind of cool thing, is a scary thing really, is he knows you're checking him out, and he reacts to it. So it's a little intimidating, because he starts to feel like a real person in the room with you. And they did the work though to get that right? There's a full body scan, they got motion capture, his voice, it all works together to create one of the most amazing characters in VR today. I can't wait for people to get to check it out for themselves. Once you start seeing characters like this, and full room scanning, it's hard to go back to simple 360 video. Maybe that acts as a gateway content for people with HMDs that don't support positional tracking, or maybe this is one of those things the community will decide what is more important, fidelity or access. So what are the questions are there? I'm going to quickly go through some of the common ones we hear. VR isn't social. First, that's like saying games aren't social. Right? You don't play Team Fortress or League with friends. Games are already social. The cool thing is that VR actually amplifies that. No longer are you looking at each other's avatars abstractly, but you see each other's real movements, all the information and context that goes with that. And it can also be social locally. Games like Fantastic Attraction, pictured here. Right? Watching your friends try to solve the puzzles and egg them out with their crazy ideas is sport of its own. Some other quick points. All games will now be VR games. No, VR is additive. It is another platform from games, but this doesn't mean an end to traditional games that you're used to. And every good game makes a good VR game. It'll take forever to set up each time you play. Not true. I can use our own setup for example. You set up and define your play area once, and then bam, you're good to go. Any other time you want to play, you just pick up the HMD, and pick up the controllers, and you're ready to play. If you die in virtual reality, you die in reality. Yes, this is the one thing Hollywood got right. All experiences will be short mini games in VR. No, there's full games being made, but what you're seeing is one of the problems as we try to demo VR, is we have a limited number of kits that show, so you do short experiences. But there'll be a wide range of experiences at launch. Ask kidding about that dying VR thing a few slides back. Your body's already dead, and you're just brains living in glass jars. You're in virtual reality right now, and you don't know it. 3D TV failed, so VR will fail. 3D TV didn't change the way you experience the content. Virtual reality fundamentally changed the experience. It's a poor comparison. We've talked about immersive experiences before, we've talked about interaction before. But never before did we break through the fourth wall and put you in the scene. This really does change everything. We will adjust and get used to. It won't be special after time. I can only speak for myself for familiarity. And I know this. Presence is still strong enough for me that when I'm ducking behind a desk, I have to remind myself not to put my hand up on that desk as I get back up, because I'll fall down. And that part of your brain, that lizard brain that keeps you alive now, it stops you from walking in front of cars, keeps you sitting on that chair, VR taps into that. It taps into that lizard brain. And for me, I continue to be behind the VR every day. Oh, by the way, don't just plug about your brain being in a fancy glass jar. Those are just narrator or mirrors for the world's future inhabitants. And you need a dedicated space for it. So I'm going to thank Cliff Blazinski for this. He has a whole Tumblr on bad memes of why VR is going to fail. And I borrowed this one from him. He's right? You have a special place for your gaming computer, your console, your TV, that treadmill that you don't use. You can scale from being just on your desk next to your monitor to a dedicated room for it. Remember, what is one takeaway from this talk I want you to have? You don't need a 5 meter by 5 meter room. That is currently the maximum. And that's actually going to get bigger, but it's not a requirement. And so that's it. I can stop talking at you and instead we can have a conversation about this. There's a time for your question here, or if you also hate standing up and talking in front of people as much as I do, I'll I'll be hanging around afterwards, or you can come over to the Vive demo area and chat with me. So if you want to ask a question, there's a microphone there.
So you briefly touched upon it, the idea of isolation and that it's not a social activity. So I think. Try one second. Okay. Is that better?
Yes.
Right. Gaming has become a continually isolated pastime, in my opinion, compared with tabletop D&D or local co-op consoles. VR seems to emphasize this isolation. Is that another failure case?
No, actually, I think as I said in the one slide, besides the local VR, which Fantastic Crafting is really fun. First time I played, there's like 20 people behind me all laughing at my continuous failure. But to say that it's isolating is you go over your friend's house every night and play D&D. For me, I play a game almost every night. I'm addicted to Battlefield 4. I play Team Fortress on Team Fort every night. Something that matters. Right, but I play those on certain servers with certain people and interact with them. And so I think that argument normally comes from guys like me who aren't social about their gaming already. But I think gaming itself is social. VR really does help that. When you see somebody else doing this when you're talking with them, you're like, hey, all right. It's normal social interactions you have, and I think that's really important.
I might clarify a point in terms of physical isolation versus ability to communicate and so on, but actually physically being isolated from other people in the same room, for instance.
I mean, when you put the headset on, you're concentrating on that. I mean, that's for sure. But like I said, when you're doing something like Fantastic Contraption, you can hear what other people are saying and laughing at it. Actually, one of the more interesting things on that's the flip side of it that I don't think people think about is right now, when you're watching a movie at home, are you on your phone? Are you on your iPad? Are you essentially splitting your time between a lot of things? So I think a lot of content's become shallower because of that. You have TV shows, you have reality TV shows, it's just garbage. And your mind can just sit there and not have to worry and follow along because it's so obvious and so big. But VR brings you back to a place where you're concentrating. You're focused on them in a way you haven't been for a really long time. And I think that's going to be interesting to explore as people are able to do kind of more in-depth, more mature content of talking about and exploring ideas like empathy, where you are in that space, you're in that space long enough that you buy into it. Not to say it's a deep experience, but for GDC we had a fishing game how you guys make a rail sim, dovetail game. And I would go in the morning and I would play the games, nervously just trying to go through and make sure everything was good for GDC. And there'd be points where I played the fishing game for so long because it was relaxing that I was sure the controller I was holding was a fishing pole. And that for the next demo, I was going to have to get rid of the fishing pole because there's no way I could poke the things I needed to poke because the fishing pole's too long. My brain was so far gone that I had to take the headset off and look at the controller and then put it back on. To do that with something as simple as that is going to be interesting to do something where we're actually wanting you to feel something, wanting you to understand what it's like to be somebody or be in their shoes. And so I think those possibilities become really interesting in a way that other mediums don't allow us to explore.
Thank you so much, and thanks for a really thought-provoking talk.
Okay, I'm going to be a bit greedy here and ask two questions. One, is Half-Life 3 going to be in VR?
We were kind of betting if that was going to get asked.
And two, aren't the cables going to limit the ability to interact with the movement as you turn? Because when I've tried that sort of you go and everything, headset on, and you always find when you get to a certain point, obviously the cables are going to limit that. Are you eventually going to try and do wireless, or is it just?
Like I said, wireless has a lot of problems. I mean, people understand that point I was making about that is wireless has been around for a long time. There's a lot of people that want wireless. Be faster and more data. So that problems people have been on. Among other problems like the panels and the tracking, they're all new VR, and so we'll see those kind of take off in a different way. But wireless can be really hard. And so what we've seen is, so the controllers are wireless, and they like to have input, where you can kind of be free that way, and the cable will actually get thinner. And once you do it enough, you kind of get this cable management in your head, where it becomes less of an issue. You see the issue with the cable more as somebody new or somebody in demo the first time. Is you get more and more used to it. I regularly in long sessions doing a lot of things like fantastic traction, we move around a lot, and the cable becomes a non-issue.
Yeah. Okay. Oh, well, thanks.
We wish there was no cable, but there's just physical limits.
Yeah.
So.
Yeah. You didn't answer my first question then.
Said no.
Hi, I've also got two questions. Don't really know about halfway through. Is there any limitation to how long you can actually use the VR headsets? Like, can I actually go on for like 3 hour sessions, or is it like only for 1 hour, 3 hour? Mine gets a bit confused.
There's two things. One is the fatigue, visual fatigue. And some of the early headsets, you get real visual fatigue where you just kind of stop. The good thing with low persistence is we have low persistence and you have a focus length that goes on for infinity. It's actually more relaxing than almost looking like this. So that fatigue doesn't set in. And then it's as long as you want to go in there. We have some people looking at like, is there some sweet spot or not or what? But we've had experiences that are long. I've spent hours in side sticking and holding a fishing rod and seem fine.
The other question is, will there be a point where the whole body will be able to be seen in the virtual reality? So like, I can stare my hand and you can actually see me move my fingers.
So that's one of what's kind of like the perfect world that a lot of people are looking at. And really what it comes down to right now is tracking all of that in real time without latency. So even something like the Move, which does a nice job of tracking a lot of the body. There's a latency in there you don't notice because it's on a 2D screen that you're looking at versus you physically moving and playing around with it. So that's where it becomes problematic. But that's the kind of thing that as we get further and further advanced, that's the kind of thing people start pushing on. Some of the input schemes now have it where there's something here projecting out. So saying you hold your hands like this, the problem becomes where to hold my bow, where to hold my sword, like this. And the longbow actually came from the test that we would call the bow and arrow test. The input had to be able to track from this. What's tracking my hand back here? So I just included it from anything in front. So what's tracking it from the back? And that's why we put our sensors there front and back, so you have full 360 tracking of your input. So you need to have that as well. Including your inputs easier than your head in a way, in the sense of you're moving so much that it's easier to include. And so the body tracking has that problem. It also just has a problem of lack of the haptics. It really is like, you don't slam your hand down. I mean, when I say haptics, a lot of people think rumble pack. But really, it's still subtle, right? And that's what you just want. And your hand's good enough that you're holding something and you pick it up, like squeezing the trigger, and you get that little click feeling. Your brain's not that bright on some things. It's like, yeah, good enough, all right. Yeah. And you won't have that with that.
Yeah, and also when it's like if you're going to hold something hard, like
yeah.
And I can actually feel the value. And it's like, that's what I think we can actually take it.
But it may be once we get full body tracking that you're like, hey, that's fine, I don't have haptics. I actually still prefer that better. And that's one of the things, a lot of this is coming down to. I mean, there's a lot of lip service always said, oh, the community, we're really looking at you. But no, I mean, seriously, people are going to decide. People are going to decide what experiences they like, what input they like. Right? This is all going to be out there now for the community to decide because this is so different than anything else. We don't know, right? We've used it a bunch. We've made a bunch of choices based on our usage. We've purposely given out to a bunch of people at work, everyone at home. Everyone at Valve goes through the demos. Like, we've gotten thousands and thousands of people through the demos, and all of those demos are play tests to see what people like and what they want. And so, some of those questions we'll find out just based on how people react and what they choose.
Thank you.
So we got time for, I'm afraid. Thanks very much for coming, and thank you to Chet from Valve.